Hi. Okay, so today we are looking at velocity time graphs. We're going to be able to read a velocity time graph and use it to calculate. Well, I just stopped writing there. Calculate something. That should be acceleration, or maybe just calculate. Um, Obviously, wasn't paying attention. But the starter. Hopefully, I've been paying attention when I wrote these ones. What is the equation to work out speed? Or what is the equation to work out velocity? Similar. What's the difference between distance and displacement? And what does a straight horizontal line represent on a distance time graph? Okay, answer the questions, pause the video, and unpause when you're done. Okay, cool. So, what is the equation to work out speed? Speed, silly sauces. Speed is equal to distance over time. Excellent. What's the equation to work out velocity? Similar, very similar. The velocity is displacement divided by time. What's the difference between distance and displacement? It may be easier to use a diagram. So if I have a point A, and point B, and point A and B are, I don't know, 8 meters apart, that would be the displacement. How far apart one has been displaced from another. But how I get there, depending on my journey, you could go like this, wiggling around. The distance I travelled would be much farther than the displacement, or a straight line between the 2 points. The distance is how far you've gone, and the displacement is how far apart are you from where you started. So if you walk in a circle, your displacement is zero. Basically, like you start in your house and you go around the block, and you come back to where you started, you've moved nowhere. Your displacement is zero, but you've walked, your feet are tired, you've travelled some journey, the step count on your Fitbit says you've stepped. Doesn't mean you've not moved. The distance you've gone, so how many steps you've taken, how far you've gone, but your displacement is how far away from where you were, nowhere. What does a straight horizontal line represent on a distance time graph? It represents a stationary object, as in something that isn't moving. So that was distance time graph. Let's look at some speed or velocity time graphs. What's different about this graph? So what's the difference between this graph and the graph that we looked like before? It's the axes, you say? Yes, correct. The axes. Across the bottom is time. We knew time was going to be on the bottom because we can't control time. Well, you can't. Speed is on the y-axis. And speed is basics. It looks the same apart from the word speed, as opposed to distance or displacement. But do they mean different things? This is a speed time graph. So if we look at this graph here, at the start, it's got speed 0. And then after 10 seconds, it goes up to speed 2 meters per second. And then here, it goes up to speed 3 meters per second. So what's it doing for the first 10 seconds? It's actually increasing speed. It's getting faster. What's happening here? Traveling at a constant speed, horizontal. And then here, between 60 and 70 seconds, speed is 0, not moving. Let's look at the more general versions of this. We did this before in a previous lesson, but the difference between this one and the one in the last one, the last one was the axes. This one, the axes are speed for y and time for x. Spend a minute, copy that down. It's the dishwasher making strange noises. On my stomach. Okay, so what does a straight line mean on a speed time graph? On a distance time graph, a straight line meant that the object wasn't moving, it was in the same place. But this one is saying, if this is, say, 5, at time 1, it's going at 5 meters per second. At time 2, it's still going at 5 meters per second. 3, 5 meters per second, 4, 5 meters per second. So actually, whatever's happening over across this whole time, it's just going at 5 meters per second, for example. So a horizontal straight line is the same speed everywhere. So the object is traveling at a steady speed. It's not going faster, it's not going slower, it's just traveling at a steady speed, as long as that line is not on the bottom. So here we have the next example, almost the same line as again, using like the same graph, we're just upgrading the axes. So here we've got no speed, and then as we go up, the speed's increasing and increasing and increasing and increasing. How would we describe this? We describe this as accelerating. When you've got not horizontal, a diagonal line, you have the object is accelerating. Here we have two different lines. What's the difference? We have a steep line and a shallow line. So this one gets up to a top speed very, very, very quickly. And this one here takes a long time and it doesn't reach anywhere near the same speed. You know, this first line might be, for example, a Formula One car, where in a matter of seconds they're going 100 and something, 200 miles an hour in no time. Whereas this one might be some normalish car, where after 2 or 3 times the original length of time, it's barely going at half the speed of the Formula One car. So steeper gradient, faster acceleration. So this is a steep slope, so it's accelerating harshly. It's a gentle slope, so it's accelerating slightly. What's happening now? Speeds up, constant speed, down to 0. This means it's slowing down, it's decelerating. Speeding up, constant speed, deceleration. So a downward slope on a speed time graph is when the car or the object that it's representing is slowing down. Now, this one is slightly different to the one that we had before. Look at the axes. Time on the x-axis, but on the y-axis it's velocity. What's the difference between velocity and speed? Direction. And notice this graph actually goes below the axis. So this one has a negative section, so a negative velocity, and a negative velocity in relation to a positive velocity. If one goes positive, negative is going the opposite direction. So the picture shows a velocity time graph for a lift inside a building. The sections of the velocity are labelled with letters A to E. In this graph, upward velocities are shown as positive and downward velocities are shown as negative. And the question is just asking, during which sections will the lift not moving? So what would you have to expect from that? If it's not moving, what's its speed or velocity going to be? Yeah, so A, B, C, D, or E. Which sections is it not moving? Which sections is it moving upwards? A, B, C, or D? And which section is it moving downward? Can you describe? 4. Can you describe the velocity of the lift during B? What happens? And did the lift have the same speed when it was moving up as when it was moving down? Explain your answer. More information on the same question. Calculate the displacement of the lift during B. Ooh, displacement. Do you remember the equation? Velocity is displacement over time. If you rearrange that for displacement, you can work out what the equation of displacement is. 7. The lift started on the second floor at time 0. Each floor of the building is 2 meters high. Describe the stages in the lift's journey. Here we have, next question. Look at the distance time graph of a motorcycle below. Match the sections A to G by copying the labels below. So basically, write those words down. Lower constant speed, distance in meters, stopped, decelerating, time in seconds, constant speed, that's 2. And accelerating, and then just...
Sorry, I don't know that.
And then just write the answer behind. Then write the letter to match it. Good. This one. Look at the distance time graph of the motorcycle in question 1 and answer the following question. There's a motorcycle. Hang on. There's a motorcycle. There we go. It's a distance time graph. Complete the statement in the general property of a straight line of a distance time graph. This is easy, it's just distance time. So fill in the missing words. So number 9, number 10, and 11. Gosh, hardly anything to do. I believe in you. You can do it. Oh, there's one more. Damn it. Copy the graph, add the labels. Can you do it? Yes, you can. And this, there we go. This is a train, and you need to use this one for this graph. So, there we go, we're at the end. So, answer the questions, write down the answers, just the answers. Don't need to do anything else. Just write down the answers, take a photo, and send your work to your teacher. Good luck. Love you. Bye.